Hi, um, it's almost in the morning. I can't sleep. I thought I might as well do a stream. I haven't been doing it for more than a week now. Um, I hope the audio is clear. And I've got some new gadgets that I'll be using today. And the approach will be slightly different than the usual one. What I'll be doing is um, take 20 minutes to answer the question theoretically without writing the code. I know I say this, I actually end up writing code. And it turns out maybe writing the algorithm is easier, but converting the algorithm to the code might be slightly trickier. It's not hard, but just a little trickier, and you have to cater for edge cases and stuff than the general algorithm, which you would overlook. Okay, so let's start the timer. 20 minutes. So the first two questions that you see here, okay, you can't see anything there. So we'll be looking at a couple of questions, I guess 7 that's on my screen. These questions are for someone else, but due to potential copyright issues, I'm not showing them as whole. But for first 20 minutes, I'll be looking into answering them, and then the next 10 minutes, I'll be reviewing the solution and think where I messed it up or couldn't figure it out. That's 20 minutes actually quite long, I think. But when I start doing questions, the 20 minutes becomes like 2 minutes for some reason. I think I know the reason though. Okay, what we can do? We're gonna do the questions, and so the first two questions I've done this before. I did this with pen and paper. I recorded that thing. I did not stream it because it was not, the production quality did not seem satisfying to for my standards, so I did not put it out live. It's on my hard drive somewhere. Maybe I can release that as a throwback when I got like ridiculously famous, which is probably never. So I'm never gonna see that. Okay, so what we have here, the first question is classical maximum subarray. Let's start the timer. I probably wouldn't need that long because I've already done this sort of a couple of days ago. Okay, the tool that I was telling about was this. I'm just experimenting, so bear with me. Maybe I should full screen this thing. Okay, so maximum subarray of size k. Let's get rid of this. There's a lot of echo. Okay, maximum subarray of size k. It's an easy question, but it took me a really long time to figure this out. Okay, so the basic algorithm, what we can do is, we can just do a for loop starting from I to n, left to right, and then for each item we take the next k elements and sum it together. So this will be 1, this will be one subset, this will be one subset, this will be one subset, this will be one subset. So we will essentially have two for loops. One is I to n, another one is from I to I plus k, or maybe the first loop can be n minus k. So since we don't have to move past this, we don't have any set here. Plus 1. of course. That's the edge case we need to consider. Okay, so that would be the brute force, and then the complexity would be O n squared. Remember, I'm answering this with confidence because I've seen this question just a couple of days ago, not because I reached what they call in meditation as a word, enlightenment. Yeah, no. So that's the naive brute force approach, but we can optimize it, since every time we move from here to here, we are actually overlapping the summations of numbers. So what we can do is can have two pointers, the starting pointer and the ending pointer. So when we have 2 1 5 1 3 2 in a array, and this would be this would be this. Okay, that would be this, and this would be this. So 0 1 2 3 4 5. Okay, and so what we have is essentially a start pointer and then an end pointer, SP, and a end pointer. So with these two pointers, as we move over, what we have to do is, once we are done computing the sum, and we will be moving over to computing the sum, what we are doing is we are removing 2 from the sum and adding 1 from the sum. That's the invariable that's here, and which we could exploit. So what we have to do is, like current sum, we have to minus the previous that's going out of the window and add the one that's coming into the window, which is the I, or I plus n. Okay, or in this case we're not using I, so it's just EPSP, starting pointer, ending pointer. And so the condition would be, what would be the condition? So this is the starting pointer, this is ending pointer. As we keep on adding to the current sum until we keep on adding until sum is less than k, or distance between sum and EP is less than k. Okay, so okay, so maybe we can trace through this. Okay, we start with start pointer, end pointer, and then since end pointer minus start pointer plus 1 is less than k size, so this is the condition. What we do is we just simply add to sum is equals to actually we should start EP and SP on the same pointer, and then we add array end pointer. So if end pointer minus start pointer plus 1 equals less than k, we add to the sum. We can start with 0 initially, and we keep on doing it until and then we increment end pointer plus equals to 1. We increment end pointer by 1, so end pointer eventually will reach It'll reach 5. Okay, let's say EP, and then the sum will be here it will be 8, and then SP minus, this is 2 minus 0 is plus 1 equals to 3 less than or equals to, more than or equals to. So this is where we handle the edge cases. It's very easy to overlook these edge cases unless you trace them through. So less than or maybe, oh yeah, fuck, it should be more than or equals to. If more than or equals to, I think, yeah, no. Equals 8, 3 is more than or equals to k, so we add these numbers to the sum. Okay, before this it would have been 3, but after we enter this number, the current SP will be 5, and then it will become 8, and then ending pointer will move to the next one. EP will be next. So when less than, so this is less than or equals to, so this should be less than. Else what we do is, so once we do here, you realize the SP is still here. So what we have to do is we have to decrease starting pointer until it meets this condition. So what we do, while EP minus SP plus 1 more than k, we decrease starting pointer by 1, and then sum. Okay, we shouldn't do that first. We should minus the sum first. Array starting pointer, so we minus 2 from the sum, which is 8 right now. If you've been following, it's 8. So minus that 2 from 8, so the sum will be what, 6 now, and then we decrease the starting pointer by 1, so we move the starting pointer to here. Okay, starting pointer. Now the condition here is met. Starting pointer is 1, ending pointer is 3. 3 minus 1, 2 plus 1 equals to k equals k is 3. So we add this sum again, and then we move the pointer to the next, and then this step occurs again, like starting pointer, and then we decrease. But here we're not updating the sum or considering the sum to anything. So all we have to do here, you have to keep track of a rolling maximum sum. So maximum sum equals to infinity for the time negative infinity, and then every time it meets the condition you have to update max sum equals to max. So we pick the max of current maximum sum, max sum over the sum. Okay, so that's what we should be doing. I don't think this code actually works. Let's see how we're doing on the timer. We actually spent 12 minutes on this. Yeah, on a question that I've been looking at for third time, technically third time. Yeah, I've seen this once. Did not attempted, but seeing this for third time. But I think okay, there's no outer loop. We are missing the outer loop. What are we missing here? What is that we are missing? Not sure if you can see my face over this mic. Are we missing something? I feel like we're missing something. So EP starts with 0, SP equals to everything starts with 0, and then if EP equals to this, then we sum, and then we stop. So how can we keep going? We're decreasing SP. No, we should increase SP by 1, not decrease. Move it to the right, and then maybe we should stop when n pointer equals to n. This is while n pointer is less than n. Do this. Okay, let's do it. While n pointer less than n, do this whole block. It doesn't make any sense, but sure. Oh, by the way, if you haven't already noticed, I'm kind of a little under the weather, so to speak. And that's one of the excuses that I'm using to not working on my things. Okay. We're reaching the 4 minutes mark, but I think we can just jump on to the solution. Screw this. Okay. Which is definitely not something I have in on the screen right now. Wait, how to use this? Yeah, I'm still figuring out how to use this thing. Okay. Yeah. While n pointer is less than yeah, we could do this. Less than n, we sum the value and then increase the n pointer. Actually, we can refactor this code a bit, because you see here we are using the same element. Maybe we can optimize it and refactor it slightly. But the logic seems to be roughly the same. Yeah, we only consider okay, so there's one thing, yeah. So when these evaluations happening, we should not be doing when the start pointer is like at 0 and end pointer is like at 2. Whenever the size of subarray is less than 3, we should not be evaluating those sums. This is error. What we could be doing is, while EP is less than n, straight away sum up the value, add that EP to the sum, and then add a okay, so okay, so you can see when you start, this is fucked up. When you start doing a question too many times, you kind of memorize things and just pull it out of your ass and put it where it doesn't belong. So this is actually a solution for probably the next question. Let's see. Yeah, it's probably a solution for the next question, and it might work, I'm not sure. And yeah, it probably could just get away with this just by doing a if instead of a while. If EP minus SP plus 1 is more than K, this logic could come under this, and then we get rid of this, and if so, as you can see, I'm clearly explaining this very well. Okay, there's a timer that's going off. Thank you. Oh no, I just look at the stream. Seems like my face is blocking the solution. You guys have no idea what I'm talking about. Oh my. Sorry about that, mate. Yeah. Okay, so yeah, and if sum equals this is and end pointer is more than okay, so this thing can be simplified as well. This thing over here can be simplified. This would make sense if you're using the while, but here it doesn't make sense. We just need to account when the end pointer starts becoming larger than this. We moving everywhere here, we have to minus a value. we only keep adding on, and starting from here we have to start minusing values. So what we can do is like end pointer, the logic here be end pointer more than or equals to, no, I don't think equals to, more than k, more than equals to k minus 1. That's what they put it in solution. K is true. If it equals to 2, we start. Okay, when it's equals to 2, so when it's equal to 2, so the line becomes here. Moving, starting here and forward, we can consider only values from here are considered valid. Only subarrays from here are considered valid. And then we have to minus the last number. And then we minus a subarray. And before we minusing the subarray, we have to consider the sum that we have. Yeah, I don't know. At this point, I'm like, am I just reading the solution to you? Excuse. It's only 5 a.m. Why am I sleepy? Yeah, I'm lost. This is a question that I did multiple times. Why am I still getting it wrong? And this is easy. It's like first question. Okay. Window start pointer, start point end pointer is more than or equals to k minus 1. What we do is minus window dot start. Okay, so this is why when we do here, they're suggesting we minus window dot start, but before that we have to evaluate it. So when we minus a value, it automatically be considered for the next task. Maybe I could bring up the paper. Maybe I could bring up the paper that I used for like previous code. That was like a bit cleaner. My version that I remember was much. This one is a bit tricky. They refactor it, but it's not straightforward. Okay, let's move on to the next one. Since I clearly did not do well on this one. Okay, smallest subarray with given sum. How is the stream coming? Okay, I just have to be aware of my face. Maybe I can move. Oh no. Maybe I can move these to here. I guess so. Is it live? I think it's live. Okay. And let's get back and set the timer. Next question. Stick with black marker for now. My throat. Oh my god. Let me get something. Okay. All right, I think I'm just whispering at this point. It's 5 a.m. I don't want to wake up my family members or make them think that I'm crazy. I'm talking to myself, which is true. Okay, smallest subarray with given. So okay, so the difference between previous question, as I elegantly explained by myself, and this one is that the subarray and the previous one is fixed. The window size, so to speak, is fixed. So this is a big takeaway. We should write down. Window size is not fixed like previous question. This is something we have to no questions, just question. Have to take away. So here the window size is not fixed. It can be any size as long as it's as the sum of 7, the number 7. It can have any size, but it can have any size, but here we're looking for the smallest one among the sizes that add up to 7. We need the smallest one. Okay, so here is where the while would make sense, because the pointer here, we have to move towards the right, and we not necessarily have to move just one, but we could move as many as we want, as long as it fits the condition, fits the size. Greater than or equals to, so that's another thing. So it has to be greater than or equals to. It's not just greater than 7. So until it's greater than 7, we can move the pointer to the right, I guess. Okay, so we have 2, 1, 5, 2, and array. 0, 1, 2, 3, 4, 5. Okay, we have these, and the sum equals to 7. The sum has to be 7. We can start with the same approach: starting pointer, ending pointer, and so what we can do is just, as long as the sum is less than 7, we move the start ending pointer and keep adding the number to the sum. Okay, so what do you say? As long as the current sum is less than 7, we increment the ending pointer and add the value of the ending pointer to the current sum. Okay, so while should we write code right after we explain it? Maybe not. We do that, and then once it becomes the size greater than or equals to 7, for here instance, this is 8 greater than or equals to 8, these 3 triplets, we take the length of ending pointer minus starting pointer plus 1. So here it will be 2 minus 0 is 2, plus 1 is 3, so the size of 3, and save it as a current maximum, or so current smallest value. If it's smaller than the current smallest value, we update the smallest value, or maybe answer. If 3, yeah, I think I explained it fine. And and then we decrement the starting pointer so that it becomes less than 5, and then we increment the ending pointer again. Okay, so you could see here there could be edge cases where you decrement one number but it still does not meet the greater than equals to criteria. For instance, if you decrement 2, these three numbers would lose the ending pointer is here, ending pointer is here, and then if this is a set, then if you move these out of the window, you could see that this is automatically fills the criteria where did I got the question right? 5 equals to 7. Is less than 6. So once we remove this number, it becomes 6. This is what I call public humiliation. God. Let's see. I need to think out loud. What am I thinking? So greater than equals to. So when we get to, yeah, don't use your brain power too much. Just write it down. Okay, start with start pointer while it's less than here, and then we move end pointer to here, and then so it becomes 8, right? And then we update answer to 3 because that's what you get, like the length minimum subarray is size 3, you get greater than equals to 7, which is from 0 to 2. And then what you do is decrement the starting pointer by 1. Starting pointer becomes this, ending pointer still remains, so the condition greater than equals to does not meet. So what we can do in that case, we can move the starting ending pointer again to EP. So in this case it becomes 8, so it meets the condition. The size is still 3, so again we maintain the size. And then so now since it's larger than equals to, it meets the criteria. Let's try to minimize it again. It's starting pointer moving starting pointer to the right. In this case it's 7, starting pointer 2, and then ending pointer is 3, and then we'll get answer 2. The length is 2. Then if you keep on doing, and then we'll probably get the answer here. But there's something we're missing here. So far we have been moving the starting pointer by 1, but what if there's like 1 1 1 and then let's say 6, something like this. Okay, so you starting pointer is here, you move ending pointer, you move ending pointer here, still not, you move ending pointer, and then there's like a couple of numbers, let's say 1, and you move ending pointer here, starting pointer, ending pointer, and this meets the criteria. The count is now effectively 9, just meet the criteria, so we move as by 1. However, so this number meets the criteria as well, This meets the criteria as well. Okay. Okay, this meets the criteria as well. But again, we have to move starting pointer as, so we can't just fix amount of move one and then the end pointer will be equals to, so we can't do that here. We have to move the starting pointer until the sum meets this condition. So move s until the sum is less than s. It's less than 7. Okay, so this will be a small while loop, and then after that while loop we move to the right. Excuse. Okay, so the code might look like, I don't know, how do I put this? How long? We already spent 12 minutes again. Like, we finished both these questions in 12 minutes, but actually I enjoyed the answer, I think. Okay. If you're into ASMR and enjoying my weird noises, have fun. Okay. I hope I'm not whispering. I think I'm whispering though. That's alright. People are fetish for whispers. Don't judge. Anyway, okay, the code would look like, we have to go from, this is I and this is N. We have to go I to N. Ending pointer has to go to I to N, so we can just say while I is less than N. Should we use another color? Maybe blue. Yeah, okay, let's continue. While I is less than, this is less than sign, I is less than N. We add some while ending pointer, is less than N, we add array current ending pointer, and if some more than or equals to k into s, okay, so this is s here, we consider answer equals to min of answer versus ending pointer minus starting pointer plus 1. So we can take the minimum and update. This is if s is larger, okay. And what is the case where we move the starting pointer? We move starting pointer when the sum is larger. So when the sum is larger, we start doing while. So inside this sum, I guess, I'm not sure. Okay, while yeah, no, this is not going anywhere. while sum is larger than equals to as, what we do is sum minus array start pointer minus the value and decrement the starting pointer, increment the starting pointer, so it moves to the right, increment, and then we do another deduction, so we keep moving on starting pointer until this condition breaks. And once the condition breaks, we move on to the main loop, and then main loop just adds the ending pointer, but we have not added ending pointer anywhere here. So what we could do is like oh my, add ending pointer. So this is the outer loop level, ending pointer plus equals to 1. We got 3 more minutes left in the 20 minutes time frame. Maybe, yeah, 20 minutes sounds okay. But these are the questions that I've already experienced. I mean, did before. Experience. Yeah, this is experience. Regardless how many times you do, you just can't win. Can't win. Okay, so just +1. How would this work? Let's okay, maybe the best solution is just tracing it out. Okay, we SB equals to 0 less than n, so we add the sum, just EP is 2, sum equals to 2, sum, okay, let's trace this with different color, let's say green, sum equals to 2, ending pointer equals to 0, and then sum equals to no, so we just increment the ending pointer to 1, and then it becomes, we add it again, becomes 3, and then we add it again, this keeps this if loop, then we add it to 8. So now we add the number, and then the value condition meets, so we update the min. So now the answer is now, as EP is at 2 minus 0 plus 1, answer is 3. Okay, and while sum is more than, yeah, still sum is 8 more than 7, what we do is move the s pointer by 1. We minus the value. Okay, so s pointer is here, minus 2, 8 minus 2 is 6, and then move the pointer to here, and then the value is still, is it still less? Yeah, okay, the value now is less than s, so this loop stops, and then we increment the ending pointer to 1, so ending pointer becomes here 3, starting pointer here, then we sum the value here, so the value is 2, 6 plus 2, 8 again, 8 again, yeah, so on and so forth, I guess. And then this value is more than this, and then we consider it's still the same, and then we decrement by 1, and then increment to the next one, ending pointer. Does ending pointer move? Yeah, ending pointer moves by 1, and then wait, does ending pointer always move? Yeah, ending pointer always moves. So decrement, we're decrementing it. No, there's a bug. So you're decrementing the timer is up. Jesus Christ, Jesus Christ. Okay, I need to. Okay, fine. It took too long. The Google timer is angry. Okay, so that's a problem. So we're incrementing it every time, even though here we're only incrementing it when the conditions are not met. So we can't do it at a time. We have to do else. So the else, if it's not more than that, then we add, else we just, okay. I don't think this is right, but I want to humiliate myself, so let's look at the solution. Man. No, we actually don't have to. No, we actually don't have to do else in this case. And you can, okay, maybe I should. You don't need this, else you can just leave it. And these two things, if sum is more than s, and while these are the, okay, you can see, maybe I can use so grading color. These and these are the same conditions, and this statement over here can go under this statement. So a lot of solution that's provided in the answers are optimized version. Like this one is absolutely not optimized, not compressed. So yeah, so there's like multiple duplications and can refactor and improve the logic. So while sum is more than that, we only consider when the thing is larger, the current sum is larger than s. So we can move it inside as well, and then we minus the value once we're done, then we plus the starting window, and here we increment the ending pointer. So why I was saying else, we have to move ending pointer every step of the way, but we can move the starting pointer multiple times, right? I don't know why. Okay, look, let's think about it. Why we are moving ending pointer once? Otherwise, we won't able to finish the array. But why we are moving a starting pointer more than once is because of these edge cases. So we have these, and then we have to decrement until we meet the base case. I mean, like condition where these numbers add up to 7 or more. And here it made 7 or more. So until then, there's no point considering them because you're looking for smallest. Okay, I think I'm gonna take a break. My vocal cord is kind of maybe I had to go to sleep. I don't know. Yeah, my throat is messed up. Let's call it morning. Let's call it a morning and go to sleep. I'm not sure if I wake up with this sexy voice again. If you're lucky, I will. If I'm unlucky, I will. Okay, so this is pretty interesting. Yeah, I did it multiple times, and this is easy. This is easy, guys. This is easy, and this is taking me a while. Okay, I again realize I've been like writing behind my face, I guess. Yeah, that's alright. It's always going to happen, and there's no way I'm going to hide my face. It's like the whole point of making my video is like to promote my face. Okay, it's kind of a trademark, really. Okay, let's look at the solution. Have I looked at the code yet? Yeah, it's pretty much the same, but without the funny ifs and a bit of ordering. And I realized twice I've been using while here, for which I could use a for loop. For SP, I mean, not SP, ending pointer I have to move by one always, but starting pointer can move multiple as long as it meets the condition, and then the next time the value is considered. Wait, the starting point have to decrease until the condition breaks. Yes, the starting pointer has to decrease until the condition breaks. So when it's here, so let's say starting pointer here, ending pointer here, we decrease by 1, does the condition break? No, because we are still 8, the condition stays, and we move here at 7, the condition stays, then we move here. The starting pointer, ending pointer becomes the same, and then the condition breaks. So the next time, in the next iteration, okay, so the starting and then the end of the iteration, while we do this, while we change the starting pointer, the ending pointer will move to the next one. Starting pointer and ending pointer will be at the same point, but because of this line here, the ending pointer will move to the next one, and then in the beginning of the loop we'll be adding the next number, which is a 1 here, and then this will meet the condition again, and then we move the starting pointer to here, and then the value becomes 1, and then so on. So yeah, this requires lots of thought, and this requires a lot of thought and probably repetition and practice. Yeah, I can't think of anything else than memorizing this stuff, or like how I use while here. Yeah, people just probably just come to my mind, like, or you could run this and then you'll get some errors and then you fix it. That's one way, but here we are expected to compute all these values in your brain without compiling, so that it can be like, am I seeing a lot of likes? I think I am. That's so the next question is medium one. That probably means I'm gonna take 2 days to do this, but looking at these slides I feel I've made some progress, and the colorful slides are good enough progress for me for today. And let's end the live stream here. Thank you guys, whoever's watching. Probably not anyone, but thank you. If you guys watching this and think what you're doing with your life, think harder. Because you're onto something. Bye. I forgot what I do. I don't know how this streaming thing works anymore, because I didn't do it for a while. Should I stop the stream or wait until the YouTube stream ends? Maybe not. I think, yeah, no. I should probably just go to blank screen and then cut it off. Okay.